Okay, go, Vivian.
Okay. Hi, everyone. Thank you for joining us today. And what we'll be looking at today is the Skynet Telescope Network. I hope that you've all seen the email with the password and the username for your group. So I'm going to start out on the Skynet page, which is skynet.unc.edu, and I'm going to type in our login, which is Yerkes Workshop, and then the password, which I am not going to say out loud, and then go ahead and log into that page. So just a little bit to make this a story. Back in the early 90s, when I was teaching high school, I got involved with Hands-On Universe and really became quite impressed by how my students responded to being able to be the astronomer, get images from telescopes, and do their own image display and analysis and project lessons with Hands-On Universe, and they were quite engaged with it, and it really turned a lot of my students around. And so I became just like a fan of all of this. Let's get real data to kids, and astronomy is so engaging, and let's link them up with scientists. That's what NITARP is all about. That's what you guys are all about. You're really serious about engaging your students. So managing telescopes and getting images to kids is not trivial. Some 20 years later, we're still working on systems for making this happen. And there's Dr. Dan Reichert at the University of North Carolina in Chapel Hill has created the Skynet Network. And this has lots of telescopes on it, including the Yerkes 41-inch, which perhaps about 10 days from now will be back on the system. But these are all the other telescopes. The AR-030, for those of you who know Hands-On Universe, this is actually the Hands-On Universe telescope that's now managed by Bob Holmes at the Astronomical Research Observatory in Charleston, Illinois. Okay, so when you come to the Skynet homepage, and after you've logged in, I've already shown you our scopes. The other interesting tab up here is Observation Manager, and we'll get to that very soon. I did want to show you on the side here, there are some interesting links. There is a webcam that shows you the little telescopes in Chile. This is live. So these are the 16-inch telescopes at CTIO in Chile. And when you click on different ones, they zoom in. So these are the workhorses of the network. And Louisa, look at two masses here.
Oh, yay.
I thought that was really cool. And for all of you in NITARP, I'm sure you know 2-mass data. So
yeah, because they were done with the survey, but the scope is still around. So that's what that means.
Yeah. But the survey was done there, I presume, right?
Yes. There were two mass telescopes, and there's one of them.
Okay, so here are 6 domes, and 4 of them are open. And let's see, we'll just zoom out to get a sense of where you are. So you're in Chile, and there are the beautiful mountains. All right, now I'm going to go back and look at Skynet Live. And I really love this page because it has a whole view of the sky, plus which telescopes are open and ready to do work for you. So here are the 4 prompt telescopes that are open, and you know, we saw those 4 there. Prompt 2 is not open tonight. And this tells you where the sun is. So we don't have any telescopes at the moment that could be taking images. These are still taking flats. As you can see, it was light there. So they're doing their calibration images right now. As you click on any one telescope, if you look up at the map, it changes to a red target. So does everybody notice that?
Yes, I can see it.
This is really fun. This is fun when the telescope is slewing to your requested observation. You can, you know, the name of your observation will come up in this last column, and it's really fun when you watch the telescope go to take your images. Any questions so far?
Yes, there's a question.
How many telescopes?
How many telescopes was the question?
There are 5 prompt telescopes, but then there's all these other ones, and depending on weather conditions and the condition of the telescope, different telescopes will be available on different nights.
Okay.
Now, the Yerkes telescope has been offline for quite a while because we had the mirror taken out and resurfaced, and now we're putting on new motors and putting on a new control system. But like I said, all that should be done in a couple weeks, and then we'll be able to start using it again. This is the middle-sized telescope here. It's a reflector.
So how many telescopes you have then?
How many telescopes do you have total?
You know, it's hard to count. So whatever is here, plus, you know, I think there's some telescopes that aren't listed here. And there's 4 new telescopes being built in Australia.
So I think the answer is many.
Okay.
There's many. And they are they're rewriting the control software, which will allow more telescopes to join. So I have a couple other telescopes that are waiting for that, and then they'll be on this system too. Now, usually the way you can get access to these telescopes is you have to be part of a institution that contributes a telescope. In this case, you are part of the Yerkes group, because I know you have put in a lot of sweat equity into NITARP, and we really appreciate your scientists there, especially Louisa, and so therefore you kind of like second cousins to us here. So we're providing access because we have a telescope on the network.
And we thank you for that.
Okay, any other questions?
I don't think so.
Okay, all right. So now I want to go back and show you my other, the other interesting page, and that's recent images. So this is kind of fun because you can look at all the images. Probably the moon was really close to this object, but you can look at all the other images that have been taken. I think that whatever this is, it's not good. But this is raw data coming right off the telescopes. And a lot of times you get ideas for objects that you might like to investigate yourself. All these PGCs, this is a supernova search done by scientists in Chile. So it's really kind of fun to look and see what everybody else is doing. And also, if you've got images that are being taken for you, and you've been watching Skynet Live, and you know that they're coming in, you can watch them under recent images. Okay, so now here's the fun part. Under Observation Manager, this is where you can look at your observations, observations from your group. So your group, you are part of the Yerkes group, so there's all kinds of other things going on with our teachers and our projects. You can look at calibration images if you're trying to find flats and darks, or you can look at all observations. And so this will show you everything that is kind of either complete or in queue. So let's go back and look at our own observations. Okay, so these are our observations that I requested for this workshop. And I just put them in the last couple days. Okay, so I could show you what we already have. Why don't I do that first? This was CG4. This was the project that Sheldon and I did with Louisa. And I think there's been another CG4 project since then, hasn't there, Louisa?
No. I've been trying to work with my scientist collaborator who had some supporting data that we used for our project, and she's gotten derailed with some other stuff, so we haven't gotten back to it.
Oh, okay. So this is, the field of view here is about 10 arc minutes. This is just a quick preview of what those images looked like.
It hasn't rendered on at least my screen yet. You got to give us a second.
Okay, I'm sorry.
It's okay.
I'm kind of new to this tutorial online business.
Okay, I think my screen has stopped updating, so yes, now.
Okay, so you can see it tells you which exposure, what the exposure time was, what the filter was, and which telescope took the image. So it's an easy way to preview what your pictures look like. These are just JPEGs, and I'm not entirely sure if they're processed with flats and darks or not. Okay, so now I'm back on the observation summary for the CG4 request. This is a table, and it gives you the exposure number, and they always start with 0. And then the exposure length, the filter, and it gives you an opportunity to look at the JPEGs made from the FITS files. And you can either look at a raw one or a processed one, or you can download a particular FITS file right here. You can look at the header. So so instead of just plain downloading the pictures, you can take a look here. This white spot, I think, is probably a bright star, or maybe somebody was imaging Jupiter before our picture went through. So sometimes things like that happen. Anyway, now the other important things on this page is it tells you a summary of what your request had in it. So it gives you the RA and DEC. This is a priority 6. This is not a really high priority, but yet it went through really quickly. I asked for an air mass of 2 because, and I'll show you what that means in a little bit. And we said we are willing to have the observation on either prompt 4 or prompt 5, but prompt 4 is the one that, the telescope that took the images. I'm going to make this a little bigger. Does that help?
Yep.
Okay, so there's also a button here where you can download all of the images in a zipped file, either processed or raw. Oh, wow. Okay. I never noticed this like show only however many seconds or, you know, what filter. So I suppose, oh, that's kind of cool. So you can just isolate. this would be useful if you have a really long set of observations and you want to sort it out. Okay, so now I'm like back to the beginning, and I should have told you in the beginning what I wanted to do was go over the Skynet telescope site, show you how to get observations, and then I'm going to take you to another site which will allow you to display your images and analyze them. So those are the two main places that we're going to go. And don't worry about trying to understand everything that I'm talking about, because there's another site with very excellent tutorials that are much better than what I'm telling you about. It's just that I know you guys, and some of you know me, and so there's a little personal connection here. But
you're giving us the crash course overview, right?
Yeah,
and for the more nitty-gritty details, you can go to their tutorials on the Skynet website.
Right, and I oops, I just lost it. I sent you this link, and all these tutorials are really excellent. You'll learn a lot. So by all means, go to this Astronomy Labs site so that you can look at each of these videos. Is there anybody, Louisa, would you ask if there's anyone who's called in who can't see my screen?
Is there anyone who's called in who can't see Vivian's screen? I don't think so. I think we're all good.
Okay.
It does take a little bit of time to render, so any kind of fast changes that you make, it's going to take a couple seconds for us to see. But
okay. All right. I'll try to be better about that. And I'll try to also describe where I am in case it hasn't updated. Okay, so do we have any questions?
Does not sound like it.
Okay, so I did want to let you know that I was picking objects. This Omega Centauri is very beautiful. I was picking objects for which there are other resources for students who are blind or visually impaired. And the Amazing Space website has graphics, tactile graphic masters, and I put a link to that on the email that I sent you. One of the tactile graphics, this is for kids who are blind, is an image of the stars in Omega Centauri. So I chose this object, besides it's beautiful. So here's this beautiful globular cluster. I clicked on the preview, and
it's not updating for me yet. Give it a second.
Okay.
Yeah, it's starting to come in for me. It's almost there.
Wow.
There we go. We got it.
Okay, so you can see this is a beautiful globular cluster that you can only see from the southern hemisphere. And just a 40-second image with a B filter looks beautiful. So all of I did B, V, R, and I. These are all really pretty, and you'll have access to all of these images when you log in yourself. I'm kind of curious, Louisa, could you ask if anyone else is actually logged into Skynet?
Did anyone else actually log into Skynet in real time?
I did. This is Shellen.
Shellen did.
This one.
Lauren did.
Lauren did too.
Yeah.
Okay. So it's probably faster to see on your own screen than through this through this video. But at any rate, okay, so there's your Omega Centauri request. Let's see. We also have the asteroid Vesta. Okay, I'm going to go down here to you a little bit. Louisa, maybe you could tell me when you can see that.
What I see is scrolling through the list. I don't see an image yet. Oh, there it's coming in.
So this preview allows you to take a look at all of your images, and it allows you to check and see which ones look overexposed, which, what's the quality of the images without opening every single FITS file to figure that out. So the preview is important, and for any of my observations, I like to have a logbook that I keep separately, and I just write down the exposure numbers and notes about the files, if they're okay or not okay, and which ones that I might want to pick in order to do whatever project I want to do. So I think that's important to teach your kids.
Yeah. Hang on, Vivian, there was a question.
Where is the asteroid in this image?
Where is the asteroid in the image?
Okay, well, that's a very good question. And who asked that question?
Vincent.
Vincent.
Vincent, okay, we are going to move over to another application, and you're going to be able to figure it out. However, one of the ways that I work on figuring that out is by going to Skyview, and I will look up on the Horizon site what field I'm supposed to be in, and then get a picture of the field so that I can recognize that. And I think most of you probably learned how to do that when you were in NITARP. Let's see if I can just go back.
I'm planning on doing a Skyview tutorial in the future.
Okay, so we won't go there right now. But, yeah, so I do compare this with images from different archives, so I can see what stars are supposed to be there, and I look and see what star is there that is not in the cataloged fields. But there's other ways to find out. Okay, and
this is a visual image. I mean, it's a V filter.
Is it a V filter image, Vivian?
It's many different filters. So we use many different. You can choose whatever filters you like. So actually, let's go right now and make a new observation. So, okay, to make a new observation on the Skynet homepage, you go to Observation Manager, and then you look for this little bar at the top that says Add a New Observation. Can you see that?
Yeah.
Yeah.
Okay, so you click on that, and that takes you to a screen that allows you to make choices. So, from our group, do you have any objects that are your favorites that you would like to have images of?
Guys are awfully quiet.
BRC 34.
BRC 34, says Shellen.
BRC 34.
It might not like that name, but I have coordinates.
I know.
If I have coordinates, if it doesn't work, Vivian.
BRC. Let me just try. It's pretty good at knowing something.
Well, but this is not necessarily a common name. So, right ascension 21 hours, 33 minutes.
21.
Yeah, 21 hours, 33 minutes, 32 seconds, 58 degrees, 4 minutes, 33 seconds.
33?
Yep.
And this is positive in the northern hemisphere, right?
Yes.
Okay, so see, actually, that's a little. Okay, so we're going to call this BRC34.
And you need to pick a filter too, it looks like.
Right. And I'm going to put this in as Shellen with NITARP. Okay, just because I want to identify.
Make it easy to
whose
find.
image this is.
Yeah.
Okay, so now what this tells down here, this is a very important chart at the bottom of the page. This chart tells you which telescopes can observe this object. So this chart is color-coded, which is probably not great for everybody on the call. But this, okay, so what's on this chart? To the left is elevation with the dark black line being the horizon. Anything below this dark black line is not visible from that particular telescope, and this happens to be CTIO, the prompt telescopes in Chile. None of them can see this. Our northern hemisphere telescopes can see it for, maybe a couple hours. So it's not really positioned really great to observe right now.
Yep, not a good season.
So do you have any other suggestions? Thank you, Shellen, for that, by the way.
Sorry.
Okay, how about another suggestion? I heard
BRC27?
BRC27 is
You guys.
is also
Nice, Debbie.
it is a southern hemisphere object.
Yep.
So but it might be too low on the horizon for BRC but I'll give you the RAN deck when you're ready.
Was that Debbie?
It was either Debbie or Lauren, I couldn't tell.
It was Lauren.
It was Lauren.
Lauren.
Okay. 7 hours, 3 minutes, 59 seconds, and minus 11 degrees, 23 arc minutes, 9 arc seconds.
I think this one should be okay. That's my guess. Oh, it's kind of hard. Let's see. Okay, look at that. Okay, Lauren, good job. Or lucky job.
Yeah.
So now we have a lot of choices for telescopes. We have this highest one is red, and that is the CTIO telescopes, the prompt telescopes. But you also have a gold one over here that happens to be Gort or Hume. That's a telescope in Sonoma. The DSO are telescopes they're in North Carolina. So you've got many choices for different telescopes. Dolomiti, this one way over on the right side, this is in Italy. So our friend Kevin McCarran says he'll go work on that telescope anytime they want him to. That was a joke. Okay. So we have a lot of different telescopes to choose from. But, okay, so I have to stop a second and say that the whole Skynet website is being redesigned, largely because we have a new grant from the National Science Foundation to involve middle school kids in doing astronomy. It's called Skynet Junior Scholars. But what it does provide is money for the programmers. And so this site will be redesigned. one awkward part is, now that you know what telescopes you can observe your object with, you don't know which filters those telescopes have on them without going back and looking at the web page about the telescopes. So, Lauren, do you have an idea about a filter?
No, none. Absolutely not. Don't care.
She said she doesn't have any specific ideas, but I would think VR or I or R prime, I prime, Z prime, any of those would be good.
Okay, let's see what happens with VR and I. And is this a dim object or a bright object?
In the optical, I suspect that I know that there are some bright sources as well as some faint ones.
Okay, so I'm doing VRI and open, and so this is giving you actually 4 telescopes to choose from. So when
yeah, there's a question.
What is open?
Open wouldn't be no filter.
Okay, thank you.
Yeah.
So it'd be basically the native response of the detector.
Got it.
You're getting every bit of light that detector can handle.
Which means you can't ultimately put it on an SED because it'd be very difficult to calibrate. But you still, I mean, if you're looking for a pretty picture, this would be a way to get all the light you possibly can.
And it also often lets you see all the features that are in there with a shorter exposure. And then you can go back later and decide how you want to study this object with filters. Okay, so we're going to choose all of these telescopes. Now, I should, okay. So, and Louisa, you are exactly right. Can you see my next screen with all the red writing on it?
Yes. So there is a bright star there for sure.
Right. So there's a 7th magnitude star. So they are allowing us to have as much as 80 seconds. But boy, if there's a 7th magnitude star in there and we go 80 seconds,
it's going to blow it out. Yeah.
Yeah. So anyway, let's say that here in this column, you're going to put in your exposure times. And
no, the number of exposures, right? Not the exposure time.
The number of exposures. Thank you. And then in the last column, you're going to put how many seconds you want. So most of these detectors seem to be more responsive in the red. So sometimes you need a longer exposure if you have V or B. I don't know.
That's it. Yes, that's true. Professional telescopes too, because the objects that we study in general are fainter in the bluer bands, and it's generally harder to make a really good detector that detects blue light. So yes, this is not just an artifact of the telescopes with which you're familiar.
Okay, so let's say that we're not sure, how long to do exposures, so we might want to put in a couple different options. You might want to do 20 and 40. I hate to do 80 with a really bright star in there. So we can put more than one exposure time if it's separated by a comma. And for the clear, we might just do 10 and 20 second exposures. This might be underexposed, but I'd rather have it underexposed and go back and up the exposure time. So at this point, you could, if you had more than one exposure, let's just say we want 2 for the V filter, then you can choose between sequential and interleaved. And what that means is that it'll go through all of these once, and then it'll go back and pick up the second set of V. I think that this is a better option if you have more than one exposure that you're asking for, because if your observation gets bumped, then you will at least have one exposure in each filter, or one set of exposures. In other words, it's going to do both the 20 and the 40 for all the filters, but then it'll go back again and do the V filter second set of 20 and 40 second exposures. Okay, is everybody fine with that?
Yep. Looks good.
Now, if you were looking for a variable star, or you were doing an asteroid or something else, you might want to repeat these observations. You might want to repeat them with a certain interval. And before you start fooling around with this, go listen to the tutorials or get in touch with me so that you figure out how to do this with all the little idiosyncrasies. Okay? So then we do next, and now this is a summary of what we're asking for. And if we like it, we confirm it. Okay, look okay to you, Lauren?
It's still downloading. It's still all kind of
okay.
Not settled in yet. Can't quite read it yet.
Lisa, this might be a slow Yerkes connection too.
Yeah, I am trying to think of other solutions for this. I have a couple ideas of how to make this work better next time. But I think this works for a crash course.
Yeah, good for a crash course.
Okay, so do you see the screen now, Lauren?
Yeah, I do. I can't see the bottom of it, but I can see all the way down to 20 seconds.
Right, okay. So I'm just going to confirm this now, and now you are in queue there. Okay?
Okay.
All right, so I think this is all I want to do on the Skynet page. There's much more to tell you, but with a slow connection, it's a little bit hard. So now we'll make it even a little more tough. Maybe not. Maybe it won't be so bad. Okay, I'm going to move now over to showing you Afterglow. So, in order to get into Afterglow, actually I have a window already open with it. Okay, this is some work that I was doing earlier, and I want to show this to you, and then I'm going to close it. Okay, can Louisa, maybe you can tell me when you can see the screen.
It's still updating. Chugging. Okay, so I see a browser looking at the Afterglow page, and you've got an image that says Vesta 710786_V_051.fits. There's a histogram pop-up and some other pop-ups, and you've identified some objects in the image, 2 Tycho stars, and evidently Vesta.
Right. Okay, so one of the things that you can do when you open your images in Afterglow is that you can do photometry. You can mark up the image and put labels on things. You can stretch with different histograms, and so this is still a FITS. Well, it's a JPEG of a FITS image. What they do is they have some engines on the server that are doing the manipulation that you're asking for on the FITS image, and then it gets converted to a graphic file that is easier to show on the web. So this is all online. And in this in this particular image, I'm going to show you one thing and then I'm going to close this. But I think this is really cool. You can make a little tooltip. So when you actually mouse over the image, it tells you whatever you've written into this tooltip box. So I'm hanging on a minute till you see a little yellow box.
Yep, we got it. We got it.
So in other words, it becomes like a Post-it note.
It does. It becomes like a little Post-it note. Now, I don't think I can save this. I really am not sure. But I'm not sure if I can save it or not. But I think that's why I didn't close it. But for each of these, I wrote down how I calculated, notes about how I was doing the photometry. Okay, so
there was a question.
Yeah, on the right-hand side, there is a photometry window open, and I see the magnitude given there. That means we get the magnitude directly. Without doing photometry, does it just come like by stick?
Did you hear that, Vivian?
Yes, I did that. What this tool does is it gives you a relative magnitude. And then you have to, if you know the magnitude of a reference star in the image, then you do the difference between the relative one and a known one, and then you can apply that difference to an unknown object.
Okay.
Okay, so for example, when I went to Skyview, I overlaid the catalog for the Tycho stars, and so that's how I knew what the names of these two stars were and what their magnitudes were. So then this brighter one with the center one, let's see, actually that one's Vesta. Okay, the number 3 one at the top, you see how the circle on the image got thicker when I clicked on that row on the photometry window?
Right.
Right, okay, so that star, this software measured at 12.10 magnitude. But I had looked up that its magnitude was 9.78. So then now I can figure out, okay, what's the difference between the literature version of the magnitude and the measured version on this image. Okay, does that make sense, Vince?
Yeah, it does. And what are the units of flux on the next column?
Pardon me, I didn't quite...
He wanted to use it with something that I couldn't hear either. Say again, Vincent?
What are the units of flux?
What are the units of the flux? Probably the units of the image.
Are just counts.
Yeah.
Oh, that's the count? Okay.
It's the units of the image, right?
Right. So on the photometry settings, you can change what your radius is. You can change all these like you can in Aperture Photometry tool. And because these, especially Vesta was nearly overexposed here, I made the radiuses really big because Louisa taught me that about 20 years ago. Right?
Yes,
Absolutely. Do you remember that conversation?
Oh, yeah.
So, okay. So anyway, between these two known stars, I just averaged the difference, and then I took the measured magnitude of Vesta, and it came out 8.01. And when I had looked it up on the ephemeris for Vesta, it was like 7.9. So I thought that was pretty cool. That actually I shouldn't have put that's supposed to be a tilde in there. That's kind of bad. On my markup tool. Let's see if I can fix that. Let's see. Okay, so Vesta, I put in a little tilde. It looks like a negative sign, so I'm going to get rid of that. Okay, so there's our image, and we can save this now. We can go to File and save it as a JPEG. But I don't think those cute little tooltips download with it. I'm not sure totally. And you can either click on or off this scale from the viewer, but I kind of like that, so I'm just going to download it. So I have a folder for all my Vesta stuff. Okay, so who thinks that's cool?
Me?
Thank you, Shellen. Anyway, I think this is really cool, and it's a way for your students to do some analysis on an image and write you their notes, and then submit their assignments to you with their own notes about what they've done. Okay, but I didn't actually show you how you do the photometry, so I'm going to show that to you now. Let's see if there is, well, I probably should start from the beginning. Okay, so people are going to listen to this later, Louisa, and say, boy, it's awfully confusing.
Yeah, I know, but at least it's a crash course, right? It's a
Right.
demonstration of what you can do.
I'm just trying to get you interested enough to go listen to all those tutorials. So here's how you would start. You would start with this skynet.unc.edu/afterglow. You put in your Yerkes workshop and then your password. Okay, so now when you log in with your login and password, you can go to any of the images that have been taken with your login and password. So you go to My Images, and all of the observations are here, but they're not all complete. So does anybody remember one that is complete? How about these beautiful Omega Centauri pictures? Let's see what's in here. So we can open these all up at once, but given that, given all the trouble we had with seeing the screen update, let's just open up one of them. Okay, so here's our picture, and this works like Google Earth or Google Sky. You can just click on it and drag it around to look all over the picture. You can fit it to the window by clicking on this fit tool. So I should ask if you could see any of that. Could you see me move it around?
Yeah, I'm seeing the image move around. The star trails actually look a little trailed. The stars actually look a little trailed, like the tracking was off. I don't know if that's the web or the image.
I noticed that myself. I was hoping you wouldn't notice. Let's go back.
Sorry.
No, that was bothering me too. Let's just go back. This is where I'm going to take a quick preview because they're not all trailed.
Sorry.
And just see which one looks really nice. Okay, I'm going to go with exposure 4, I think.
Yeah, we have some people who are dropping off because it's the end of the hour.
Uh-oh, well, I should stop then. Yep, okay. So, well,
at least you've given them the crash tour, right? The
right,
crash
I
course.
gave them the crash tour. So, are there any questions before we finish up?
No, it was fine. I thought it was cool. I didn't say anything because my dogs were barking really loud in the background. I had my phone muted, or I would have said, "Yeah, that's pretty cool." So
Nice. Who is that talking?
That was Lauren.
that's Lauren. Yeah.
Okay, good. Thank you, Lauren. I'm glad that you thought it was cool, and I'll be glad to help you out if you decide to venture in here.
Okay, I probably will. Thank you very much for doing this, Vivian.
Oh, you're welcome. I wish I was a little more polished, but maybe next time.
Hey, it's a good crash course, like Louisa said.
Yeah.
Okay, any other questions from anybody else before we...
Yeah, what should I do if I want to get involved in this? I mean, what should I do?
So I sent you an email per Louisa with a login and password.
Okay.
I also made another web page that is in that email that has a bunch of information on it, and all these websites written down.
Okay.
And if you
So
get
you could go,
if you get into the Skynet website after you log in, you have access to the Skynet tutorials.
Okay. And supposing we want to observe an object, then we just follow what you just did in today?
Yes, and what's in the tutorials, because the tutorials will have less net lag.
yeah,
But once
tutorials are really good, and they're little videos, and they, what took me like 10 minutes to explain on here, they explain in about 2 minutes. So.
But the critical thing is you have to log in using the username and password that Vivian's given you, because that's how you get access. Not just anyone has access to this, but she's graciously extended access through the Yerkes connections to us through NITARP. And so if you can't find the email, send me an email, send Vivian an email, and we'll get you set up.
Okay.
And you know what, Vince, you have my email, and it would be great if you want to just say, hey, I put in an observation for this, just let me know what you're doing, and I'll be glad to help you out. And it's just fun to know, who's doing what for me.
Okay, thank you very much.
And specifically in the context of Skynet Junior Scholars, Vivian, are you actively recruiting teachers to participate in the program or teachers to be mentors? You had sent out an email for advisors, I guess.
Yeah, we are recruiting. Right now, we just had recruited teachers to be part of our education teams. And that's pretty much officially closed, but there was Louisa did put that request out over NITARP. Soon we will be recruiting 4-H leaders and other people who have informal science education groups. So if you have a club after school or something like that, we'll be recruiting people to be part of our first programs for our new project. We're looking for middle school participation, middle school kids. So if you're a high school teacher and you have, you're doing some outreach or some camp stuff in the summertime, or you work with a museum educator, and especially if you work with 4-H kids or have 4-H kids in your own household, that's our target audience for our new project.
Okay. Yeah. All right,
okay,
cool.
So,
thanks very much, Vivian.
Right. Thank you, everybody.
Okay. Thanks a lot, guys.
Thanks, Lisa, for organizing this.
Okay, thanks a lot, guys.